I'm here to try and help you understand the landscape of Lightning on the web better. We'll start by talking a little bit about Lightning and why Lightning is interesting in terms of its inherent economics. And then we'll dive into the way Lightning integrates with different web protocols, which will give you a better sense on how you can develop your application, your service, because there are different ways to integrate Lightning with the web. So let's first talk about the Lightning economy and what makes the Lightning economy rather unique than other services you see on the internet, maybe in comparison to SaaS services or to mobile application. There's something quite unique about Lightning specifically. So what is a Lightning network? Is Lightning Network a payment network, or is it something else? When I try to explain people about the Lightning Network, I first suggest them to think about a car. Like, what's the purpose of a car? The purpose of a car is to get you from point A to point B. It's a means of transportation. But how actually what's the process behind the car? The process that enables you to get from point A to point B using a car, is actually energy conversion. It's the fact that the car uses potential chemical energy and converts it to kinetic energy. That's the process of driving a car. So the purpose is to get from point A to point B, and the process is energy conversion. When we try to take this analogy to the Lightning Network, we understand that the process, the purpose of Lightning is to be able to send payments from entity A to entity B without trust, without any third parties or any intermediaries in comparison to what we have in the fiat economy. But the process of Lightning is quite unique. The process of Lightning, the way that it enables people to send payments from point A to point B, is by allocating liquidity. When technically this is known as payment channels. I think you guys are already aware with the Lightning 101, with the basics of Lightning, the Bolt specification, Bolt 11, and which is the Lightning invoicing, and payment channels, which are the core entity of Lightning. A payment channel is the entity that connects the two nodes in the Lightning network. But the ability to execute a payment is highly dependent on the ability of the nodes to allocate liquidity within the network and to assign this liquidity correctly according to the flow that the Lightning network needs to provide. I'll give you one concrete example. Let's think about a popular Lightning network service. Let's take Bitrefill, for example. Bitrefill is one of the most used Lightning network services in the internet. It allows you to buy gift cards via Lightning and other cryptos, but Lightning is supported in Bitrefill. So if I'm developing a gift card service like Bitrefill, I need to make sure that people will be able to send me payments. Meaning I need to open channels to, let's say, to popular wallets, Breez, Phoenix, Moon, Wallet of Satoshi, Blue Wallet, etc. And I need to make sure there's enough inbound liquidity enough liquidity on the other end of the channels in order for users to be able to pay me. Because Bitrefill is mostly a destination. People will use Bitrefill in order to buy and purchase items, not to use as a source, but as a destination. You can think about other sources. The wallets are sources in the Lightning topology. So wallets like Breez, like Phoenix, like Bitrefill, like Wallet of Satoshi, like Blue Wallet are all sources of liquidity. So they need to have enough outbound liquidity in order to serve their users. So the better Lightning perform its process by allocating liquidity, it better satisfies the purpose of enabling payments. So that's the we won't get, like, it's not an economic session. We can have economic sections if you want, but the purpose of this slide, and the reason I wanted to start with discussing a little bit about the Lightning economy is because there's something very unique about Lightning Network, and the incentive structure is actually integrated into Lightning Network and manifests itself in something called routing fees. Routing fees is the fee that a node in the network gets when it facilitates the ability of sending a payment or receiving a payment. So if I'm a node inside the Lightning Network and I'm being used a lot to route payment, people are routing payment through my node, I make money through routing fees. And this is the built-in mechanism for yield generation in Lightning. And it's very important because what you basically need to understand that traffic in Lightning Network generates yield. With routing fees are the manifestation of yield generation in Lightning Network. And if enough people are generating yield, they'll put more liquidity in the network, which result in more people using the network, meaning more traffic, more yield, and this circle goes on and on. So we need to make sure Lightning is being used successfully in its incentive structure in order to encourage people to put liquidity in Lightning Network, because this liquidity will increase the number of successful payments, increase number of successful payments and successful services will increase the traffic, which will generate more yield, and so on and so on. I won't repeat myself. So that's very important, because by the end of the day, what we need to do as developers of Lightning, and what you need to do in your efforts to extend the services built on top of Lightning Network, is to generate traffic. So in that regard, it's exactly the same as you were to develop a SaaS service or an internet service or a mobile application. You want as many people to use your services. But in Lightning, it's specifically important because the usage of your services will increase the usage of Lightning nodes, which will increase the desire of more people to put liquidity in the network and improve the success of Lightning Network payments. That's very important. So one of the reasons I jumped on the opportunity to be in this session is because what we need to do right now, the goal of Lightning right now, is to thrive to adoption. Adoption is the key to the success of Lightning Network. So I wanted to start this presentation by showing you the economics, the behind what goes behind the scenes of the Lightning Network, what incentivizes a Lightning node operator, and why it's such a crucial function to develop successful Lightning application. So kudos to you all participating in this hackathon. and developing services that hopefully will generate a lot of traffic to the network. I won't drill down too much to the concept of LSPs, but LSPs are meant to facilitate adoption, the onboarding of new users to the Lightning Network. By the end of the day, what we want to achieve with Lightning, we want Lightning to build to be the infrastructure of a peer-to-peer application. So there are custodial solutions built on top of Lightning, which is good, maybe, but that's not the end game of Lightning. What we need to make sure that Lightning is also being served as a peer-to-peer network, because Lightning is an extension of Bitcoin, and we need to preserve all the characteristics and all the value proposition that exists in layer one in the chain. We need to bring it to Lightning Network, and being censorship resistant, being private, being global, open, are core characteristics of Bitcoin on layer one. And if we want bring them to layer two, then Lightning, for me, won't be successful because it's something different than Bitcoin. So we need to make sure Lightning Network is being used as an extension to the core Bitcoin properties, and we need to make sure that everyone has the opportunity to run their own node and to transact with others in a peer-to-peer fashion. LSPs, but it's complicated. So it's complicated to take part in the network right now, because in order to participate in Lightning, you need to have a node, you need to run a node. You can think about Umbrel, which simplifies this process. You have a Raspberry Pi where you install the Umbrel OS inside the Raspberry Pi, and then you can spin a node. But the problem is that you need to open channels, you need to manage liquidity, you need to have enough liquidity in order to be able to route payments, and so on. So the liquidity management, the channel management part, even though node running a node is complicated enough, on top of that you need to become an IT manager and a liquidity manager in order to facilitate payments. Then it's really something that only a very small percentage of the population will do, and we want to bring Lightning to the masses. So in that regard, the concept of an LSP, the concept of Lightning Service Provider, is very important. And the principle is the same as Internet Service Provider. You don't know as a user how to connect to the internet. You just take your router and plug it to a socket at your home, and then you're magically connected to the internet. We have the same concept in Lightning. We call it not an internet service provider, but a Lightning service provider, and that's the ability of a node to connect another node to the Lightning Network. So you can see an example of Lightning service providers in Breez. When you install Breez, and you can immediately receive a payment, and a channel is open behind the scenes, and you're magically being connected to the Lightning Network, and you start making payments. The same happens with Breez. The same will happen in Synonym. That's a new player in the Lightning Network ecosystem. And the same happens with Bitrefill Tor. So Bitrefill Tor isn't a wallet, but it's a service that offers a channel creation. So you can buy a channel from Bitrefill, and using this channel, you can get connected to the Lightning Network, and you're basically connected to Bitrefill node that facilitates your payment. So that's in a nutshell an explanation on LSP. Why are they important to facilitate adoption and payments inside the Lightning? So now let's switch gears. I'm putting all the introductory stuff aside. Just I wanted to resonate it in the back of your minds while I'm talking about Lightning and the web. So it's Lightning in the web. It's really interesting. Like, why are we even discussing Lightning Network and the web? Like, are these two networks really need to be integrated? Like, what's the integration points between Lightning Network and the web? Why do we need to integrate them, and so on? Everything is every question is a very interesting question when we can talk about a single question for hours. But in a nutshell, it's important to understand that the web and Lightning Network are two completely different networks. The Lightning Network, every node is separated from what we know as website and so on. But we want to bring the Lightning Network to the web. Why do we want to bring the Lightning Network to the web? Because people are in the web. Like, people are consuming internet services, and people are using SaaS services all day long, and that's the most important thing that they do. They spend their time in Facebook and Instagram and TikTok, and there's no other way than to start adoption by bringing Lightning Network to the web. So when you think about your service that you're going to develop, the best would be to facilitate Lightning without changing users' behavior, but to bring Lightning to where users already reside, and that seems to be today either the World Wide Web, the internet services that are exposed through browsers and through mobile applications. So we need to integrate between both, although there are two separate networks. So how do we do that? First, you need to consider where the Lightning Network nodes actually run. So, for example, you don't even have to use as a service. Now, I'm talking to you as service developers. Let's say you want to develop a website. You don't have to run a node yourself. You can use someone else's node. For example, you can use Zebedee, and Zebedee provides you an API to facilitate payments, and they do that by running their own infrastructure in their own environment. It runs by the Zebedee company, and you can use the services of the Zebedee company in order to facilitate Lightning Network payments. That's one example. Another alternative is to have a hosted node in the cloud. So you can use services like the one provided by Voltage, which are similar to the Amazon cloud. You can use Voltage Cloud, and the Voltage Cloud doesn't host your internet stack and your websites and your web services. It hosts specifically a Lightning node. And you can you can buy a subscription license from Voltage in order to help you with the IT and the administration of a node. So that's another alternative. Another option is to have a self-hosted node, but also an integration stack. So the problem with Lightning nodes is that Lightning nodes are a very IT savvy kind of infrastructure. You need to understand how to invoke the services, how to fine tune the node, how to configure the node, and it doesn't provide you this infrastructure. Without you doing anything, it doesn't provide you with external interface. So I'll give you a concrete example just to clarify what I'm saying. You can take a Voltage node or you can run your own node at your home using Umbrel. And you can install LND, C Lightning, or you can start coding using LDK. But that infrastructure only helps you with the job of making payment. It doesn't provide you an external interface to your applications in order to interact using HTTP with your node infrastructure. There are now solutions from EdenPay, from Galloy. There's the LND hub by Blue Wallet. This type of software, they allow you to run a node, but they also provide an additional layer of interface that is being exposed to your services, which allows you to facilitate making payments and start interacting with the nodes. So highly recommended you guys take a deeper look at this type of solutions if you want to facilitate payments in your application, because it gives you something that the basic implementation don't yet provide. Another type of node is a mobile node. A mobile node will always be a user node. It won't be a service node. As a service, you won't run your node inside a mobile device, but your users will likely to run their nodes in a mobile device. Breez, Phoenix, and there are other wallets that run a mobile node inside the mobile device itself. So it's something to consider when you're starting to develop your applications, because a lot of the interaction will be coming from mobile devices. So how do we bridge the two worlds? How do we bridge the Lightning Network, and how do we bring the Lightning Network to the web stack? So there are different options for different use cases. I'll start by talking about WebLN, and you can go to webln.dev. The interface of WebLN is there. WebLN, you can think about WebLN like the MetaMask of Bitcoin, or the MetaMask of Lightning. It enables a service wallet integration in a very simple manner. So you can make payments, or you can receive payments through the WebLN interface without jumping between interfaces. You don't need to open your wallet, or you don't need to switch to another service in order to send or receive payments. But in order to facilitate that, you need a host. So someone needs to host the WebLN environment. Breez, for example, we have an apps section in our mobile app where we host the WebLN environment, and we run different web widgets. So you can actually interact with the Breez wallet through the web widget. I'll give you a concrete example in a second. So just bear with me. Another example is Albi. Albi is a web browser extension that hosts the WebLN extension. So you can create a website that supports the WebLN JavaScript, and it will facilitate payments with the wallet that resides on Albi. It's a super simple interface. It allows you to make a payment or receive a payment, and there are many examples out there. I just took a screenshot from the Breez application. It's a snapshot of the Bitrefill widget. When I open the Bitrefill app in Breez, I interact with the Bitrefill website exactly like I would have interacted with the Bitrefill website in a browser, but when I pay Bitrefill, it actually invoke the send payment interface of WebLN, and the Breez wallet understands that. And you don't need to scan a QR. You don't need to copy paste. You get a dialog from Breez asking you to approve the payment, and then the payment is being made to Bitrefill. So that's a great example of Lightning Network integration with web services. The WebLN interface allows us to bridge the web, the site that runs the WebLN JavaScript, and the WebLN host. And the WebLN host, in this case, it's Breez, but in another case, it's Albi. They run the node that needs to interact with the payment. So you need to send the payment from a Lightning Network node, and this is a way to bridge the two worlds. So that's one example. Another example is LNURL. So with LNURL, LNURL is a form of a bridge as well. It's an HTTP. It's something in your HTTP stack, a web service that allows you to facilitate Lightning interaction. So the main interactions, of course, is sending a payment. You do that by invoking LNURL pay link, and through the LN pay URL link you can send payments, or you can receive payments through LNURL withdraw interface, withdraw links. Again, it's a bridge between HTTP and the facilitation of receiving payments. I'll give you a concrete example in a second. Again, bear with me. I'll give you the complete picture about LNURL. LNURL as other functions. I won't get into all the functions of LNURL, but another important function is LNURL auth. LNURL auth is your ability to authenticate against an internet service without the need to do usernames and passwords. Basically, you're using your Lightning identity in order to authenticate against a web service. So that's another cool function of LNURL. And there's something called the Lightning address. You're probably come across that or came across that already. Lightning address is an email-like identifier. So I can have, like, for example, royas@zebedee.com, and people can start sending me payments to this Lightning address. The backend of a Lightning address is exactly like LNURL pay. That's why Lightning addresses are good when you use Lightning services, but currently hosted Lightning services like Zebedee, where they can provide you with the HTTP stack in order to facilitate the receiving of payments. So let's show you a couple of concrete examples. The screenshot on the left side of the screen, I took that from an internet service called Lightning Gifts. And in Lightning Gifts, you can send like a small up to, I think, 100K of Satoshis. You can gift it to your friends. And how do you do that? So you open Lightning Gifts, and you want to add. You want to top up the gift. You want to pay for the gift. That's the first step. So you can do that by LNURL. So if you click on the QR code, if you're on mobile, it will open you a wallet, a mobile wallet to pay this QR code, or you can scan this QR code using your Lightning wallet in order to pay. So that's LNURL pay, and LNURL pay LN URL Pay is different than Bolt 11 because it allows you to define a range. It allows you to define a few other parameters that helps with the sending of payments. But the real advantage, in my mind, for LN URL is LN URL withdraw, because in order to redeem the gift, that's the screenshot in the middle, you can click on the QR and it opens up the Lightning wallet that allows you to redeem the gifts without copy pasting or without doing any complicated stuff. Before an URL withdraw, the way to redeem funds from Lightning Network was to create a Bolt 11 invoice, and then you had to paste the Bolt 11 invoice, and you had to make sure both applications are open at the same time. So the process was really cumbersome, and LN URL withdraw really helps in the UI of bridging the Lightning Network and the web in that regard. The screenshot on the right side is a screenshot that I took from Stacker News, a popular Lightning Network news service where you can post links and post articles, very similar to Reddit, but it's all driven by Lightning economics. So you can tip someone that posted an article, or you can comment by paying some satoshis, and it will influence the ranking of the articles. But what's cool about this service, regardless of the other stuff that I mentioned, is the fact that you can log in with Lightning, and this is using LN URL auth, and you don't need to enter. Everyone that runs a node and services, they can use services that facilitate login with Lightning without the need to enter email, password, or have an account in some other internet service like GitHub or Twitter. So really encourage you to take a deeper look at that as well. So we talked about WebLN. We talked about LN URL. Let's talk about API, because API is something that most internet developers already work with and are aware of. And like ideally, what you want to do as a developer, who cares about all this crap, right? Who cares about WebLN, and who cares about LN URL and QRs and running a node, and where the node is running. We want to simplify everything as developers, and we just want to use APIs. However, you can use APIs currently only if you're running the entire stack yourself, or you're leveraging other people infrastructure. So in this example, you have APIs that are exposed by Zebedee. So if you use the Zebedee service, you have APIs where you can start interact and start using and making payments and receiving payments through a simple API. But the API is provided by Zebedee. Another alternative to using someone else's infrastructure is to take an existing stack like LNPay or like Galloy, run this stack yourself and expose API to the client software. But you need to own the IT, and you need to run the IT yourself. But if you do either if you're using Zebedee or if you're using LN URL Pay, by the end of the day, you're using an API which is much easier to use and to integrate and to program, because it doesn't require an external UI, and you are in full control of the actions exposed to the client. Another options of bridging the Lightning and the web is by extending existing websites. So a very cool thing that you can do with browser extensions like Albi, you can actually have an existing, you can extend an existing website. So you can think about a website that you use. If you want to bring Lightning capabilities to that website, you can use a browser extension in order to extend the service capabilities to facilitate Lightning. I'll give you an example from Albi. Albi is integrated into Reddit. So on the right, in the top, in the profile section here on Reddit, on the right side, you can see Boomi at getalbi.com, and they added this Lightning UI, the Lightning. The small lightning emoji, and by clicking on boomi.getalbi.com, you can actually start paying Boomi a lightning payment through the Albi extension. So it's a cool way to not to like recreate everything, because the alternative, if you want to do Reddit with Lightning payment, is to rewrite Reddit and to integrate Lightning into Reddit. So a cool hack is to take the existing Reddit and just extend it. So it's another way of integrating the existing web and Lightning. Another option, which is the most the most complicated option, I maybe not complicated, but the most advanced option, is using LNC. LNC is a Lightning node connector. It's WebAssembly. It's a WebAssembly. I guess you guys are familiar with the concept of a WebAssembly. A WebAssembly is a piece of native software that runs inside your browser. The advantage is that you don't need to use a web extension. The advantage is that it's native to the browser, exactly like HTTP and JavaScript. So you can write WASMs, and you can add WASMs to your web applications. And in this case, Lightning Labs created a WASM called LNC. And LNC is a Lightning Node Connect. It's a Lightning Node Connector WASM that enables you a very rich capability to interact with your node. So it allows you to invoke any API, any gRPC API that you have in LND. So LND exposes Lightning commands, what we call LNCLI. And using this LNCLI, you can control your node by creating channels, opening channels, closing channels. You can do on-chain stuff. You can do everything. You have full control on your Lightning nodes through the LNCLI commands. And with LNC, you can actually use any gRPC that is exposed in LNCLI. You can use them through a web client. So you can use your web client in order to interact with your node and provide very rich capabilities. If you don't just need Lightning, like make payment, send payment, receive payment using Lightning, but you need to get more out of your node, then you need to use something else, which is richer than WebLN, LNURL, or the API that LNPay or ZBD or Galloy supports. You need something far richer, and there's a solution. It's a new solution from Lightning Labs. So if you're interested in that, go and take a look. It's very cool, and I expect more solutions to support WASMs in the future. But this is the first implementation of that. So just to wrap up the presentation, I'll give you some use cases, and you can tell me, based on the use case, which which web integration tool you would use in order to implement this use case. We'll start with with the easiest question. If you want to provide a node management service, which of the interfaces that I covered would best suit this use case? So in order to do node management, which requires, of course, the opening of channels, closing channels, using on-chain capabilities in order to loop in or loop out, you will probably use LNC, so the interface from Lightning Labs that provides you with node management capabilities. The next use case, let's say you want to support content monetization. Let's say you have a podcast service, or you have an article like internet service like Medium, or anything that allows user-generated content. And you want to create this platform where the consumers of this service are compensating the content creators. Which interface? So let's say you do a Spotify service, or you do a TikTok service, or you do a Medium service, or you do a social network like Facebook or Twitter. How would you integrate content monetization into your service? By the way, there's no right answer, so don't. I won't put you on the spot. There's no right answer. It really depends on the specific use case. But I'll give you some examples. In Twitter, for example, they integrated Lightning payments. To receive payment, they used Strike API, which is equivalent to what I've shown you with Zebedee API or LNPay API. And they integrated, and they're integrated making payments using a standard port 11, but you could also would have used LN URL Pay. So again, no right answer depending on your services, on your specific service. Some services require streaming payments, for example, podcasts, and with streaming payments, you can't use either WebLN and you can't use LN URL. So in the case of streaming payment, you have no other choice either than use a custodial service like Zebedee or host your own environment like in LNPay. Games. So games is another very cool use case where you want to include monetization capabilities into your game. In that regard, I would suggest you to take a look at Zebedee, because Zebedee is tailored for the game's use case. Web app, there's no one answer. It's very dependent on your functionality of the web app. But everything that I've presented, starting with LN URL Pay, WebLN, API, or LNC, can work with your web app. Choose your integration based on the complexity of your app. And another factor to consider is whether it's a mobile-driven web app or it's mainly a browser, PC, desktop kind of interface. If you're using a mobile interface, I highly recommend to support both WebLN and LN URL together, because if you will run your web app inside a mobile app like Breez, it will provide you with a better user experience. But if you run the web app in the browser, then you have the LN URL capabilities in order to interact with the mobile wallets.
Cody had a question for you, Roy. He said, for a mobile node like Breez, how does the receive Lightning payments when the phone is off or the app is closed? Doesn't the node have to be online to update the channel state?
Yes, that's a great question, Cody, and that's exactly the problem with mobile nodes. So the only thing that is not really very well sorted out in running mobile nodes is the ability to receive once the nodes is offline. There are ways to mitigate that using mobile notifications. Like it's again, it's like we can talk for hours on this topic alone, but what from the list that I provided you from the list that I provided you, LNURL, for example, really mitigates this issue very, very nicely, because if you provide your users with an LNURL withdraw link and you click on the LNURL withdraw, it actually opens up the Breez wallet, and then you're able, the Breez wallet is online and interacting with the user, and the user is able to receive payment. It doesn't provide you with a way to receive payments when you're unattended in an unattended manner, but there are solutions to come with PTLCs, so stay tuned.
There's another one from Nick H. He asks you, what projects would you like to see come out of this hackathon? Anything exciting in terms of applications of Lightning that you haven't seen come to life yet?
Again, another great question. I think I touched around this topic when in the beginning of the discussion. I want to see adoption. So anything that attracts users and users being able to interact with the Lightning Network, that's what excites me. I think we haven't really we just scratched the surface with the services. I want to see a really cool, polished end user applications around content monetization, music, videos, articles, you name it, maybe social networks even. I want to see some useful utilities that people actually need in order to interact, in order that really helps them in their day-to-day life. So if you guys will be able to come up with ideas around these topics, I think that would be awesome.
Yeah, you showed this wheel of sort of liquidity, traffic, and yield. When you think about that kind of into sort of feeding circle of things, do you see there being an issue with fees on Lightning being so low that in order for traffic to sort of feed itself back into sort of yield,
Yeah.
there needs to be like an exponentially higher amount of traffic in order to generate the same amount of yield that potentially a centralized, non-inexpensive, or sorry, expensive is probably an easier way to say that, service. Does that make sense?
Yeah, definitely. And there's an article I wrote about it in Medium, really that elaborates on this point exactly. It's called Lightning is a Liquidity Network. You can drill down into it, but in a nutshell, that's my main point of concern. So my main point of concern is to preserve the incentive structure around Lightning. And if fees are too low and there's not enough volume, then people won't be incentivized to run Lightning nodes and to manage liquidity and to put liquidity in the network. So that's a problem. And by the way, that's the reason you see Lightning fees are rising lately, because there's not enough volume and there are people putting liquidity in the network, and their only way for them to generate yield is to raise the Lightning fees. So Lightning fees are rising, but it's not a good thing, right? That Lightning fees are rising. We want low fees. So in order to get to a point where fees are start to decrease, we need to increase traffic. We need to increase adoption, because if we have a high volume kind of network, then that's our way to mitigate the Lightning fees and to keep the fees low. So we need more traffic in order to lower the fees, kind of. So that's the dynamics of every economics, and that's how the manifestation of it is in Lightning. So why am I excited about this hackathon? Because I want to see more application. I want to see more usage. More usage means by the end of the day, lower fees, because it will generate more traffic, and then you won't have to take a large cut per payment. You can take a lower cut per payment, but compensate that with volume.